This is section 9.4, solving polynomial equations in factored form. Remember from our last section, polynomial equations are equations that have more than one term. We're going to be dealing with variables that are either squared or cubed or higher exponents. To solve these equations, they have to be factored. We're going to start with the equations in factored form and solve them. To solve the equations, we're going to use a property that we all already know intuitively, and it's the zero product property. The zero product property says that if you let a and b be real numbers, if a times b equals 0, then a equals 0 or b equals 0. Well, this makes sense. If we have two numbers being multiplied together that equal 0, one or the other of them must be 0. We use this to solve the equations when two factors are being multiplied by each other and the equation is equal to 0, then one or other of the factors must be equal to 0. Those solutions are called roots or the answers to the equation. I'll use these terms interchangeably: roots, solutions, or answers. Under the examples in number 1, we have a polynomial equation in factored form. The quantity x minus 4 times the quantity x plus 2, and this equals 0. To solve it, you're going to set each factor equal to 0. So in this case, x minus 4 equals 0, and x plus 2 equals 0. If x minus 4 equals 0, then x, in fact, must equal 4. In the other factor, if x plus 2 equals 0, then x must equal negative 2. In the second example, the quantity x minus 5 times the quantity x minus 1, again, set each factor equal to 0. If x minus 5 equals 0, then x must in fact equal 5. And in the second factor, if x minus 1 equals 0, then x must equal 1. In our next slide, you can see that the polynomial must be in factored form to solve it. That's the only way you can use the zero product property. Okay? The simplest way to factor a polynomial equation is to look for the greatest common factor. The greatest common factor is a monomial with an integer coefficient that divides evenly into each term. So I'm going to use GCF for greatest common factor. The example here is 12x plus 42. We have to look at the equation and see what factors the terms have in common. If you take a look at this, you can see that both terms could be divided by 6. So here, to pull out the greatest common factor of 6, we would go 6 times 2x plus 7y. Because 7y times 6 is 42. Okay, that is in factored form, taking out the greatest common factor. Take a look at these extra examples and try to work them out on your own. You can pause this recording if you need to. In the first example, you can see that the common factors are both 4, because 4x to the 4th can be divided by 4, as can 24x to the 3rd, as well as x to the 3rd. So here we're going to take 4x to the 3rd and multiply it by x plus 6. To solve this, we would set each term equal to 0. So in this case, 4x cubed would be equal to 0. That means x is 0. And x plus 6 equal to 0, so x equals negative 6. In the second example, the common factors here between 14 and 35 are 7. So we can take 7 times 2m plus 5n. Because the first term 7 does not have a variable, we do not set that equal to 0. 7 cannot be equal to 0 and is irrelevant in solving this equation. Okay? To solve it, you would set this portion, the portion with the parentheses, equal to 0. Since we have two variables, though, we still cannot solve this equation. In the third example, you have a 2x in common in both terms, so you're going to divide by 2x. The factored form will be 2x times x plus 4. Set both the 2x and the x plus 4 equal to 0. So here, x equals 0 and x equals negative 4. The last example is probably the most difficult. You want to bring all your variable terms to the same side, so you need to move the 5n over here with the 6n squared. Once you do that, then you can remove your common factors. In this case, it's just an n. It'll be n times 6n minus 5. Set both the factors equal to 0 to solve. N equals 0, and in the second case, you're going to have 6n equals 5, or n equals 5/6. The last part of this section deals with vertical motion. Vertical motion has to do with projectiles, that is, things that are being thrown into the air, things that can't fly on their own power. Examples like a ball, a rock, a feather, a javelin, okay? Even animals that are jumping and then fall into this category. We can find the height something reaches and the time it takes for it to travel its path up and down by using the vertical motion model. The vertical motion model is shown at the bottom of the slide. It's right here. Okay? You need to memorize this equation. You'll be using it a lot. The vertical motion model states that h equals negative 16t squared plus vt plus s. In this equation, h is the height, t is the time, and it is in seconds, v is the initial velocity, that is what it starts out with, the speed it's starting with, and then s is the initial height, where it begins. For the most basic problems that we're going to deal with in this section, we always have an initial height of 0. We're starting on the ground. Here's an armadillo example. If an animal, an armadillo, is sitting on the ground and he jumps straight into the air with an initial velocity of 14 feet per second, you can figure out after how many seconds he lands on the ground. The thing you want to do first is always write down your equation. Write your model first and then define your variables. We know that the model for vertical motion is h equals negative 16t squared plus vt plus s. When something hits the ground, its height is 0. There's no height. It's on the ground. Okay? We're told in the problem that the initial velocity is 14. So we're going to set v equal to 14. And because he begins on the ground, s equals 0. So we can write our equation now with the numbers that we've been given. 0 equals negative 16t squared plus 14t plus 0. To solve this, you need to factor it. We already know how to do this from doing it from the beginning of the section. These terms have a 2t in common. Remove the 2t, so it's 2t multiplied by the quantity of negative 8t plus 7. To solve this, you're going to set each factor equal to 0. 2t equals 0, and negative 8t plus 7 equals 0. So let's do that. If negative 8t plus 7 equals 0, then negative 8t equals negative 7. So t equals 7/8. 7/8, it means 7/8 of a second. Our other answer is t equals 0. But let's think about this logically. When t equals 0, the armadillo has not jumped yet. So yes, in fact, the height is 0 then, but that's irrelevant to the problem. We want to know where he is and when when he hits the ground after he jumps. Okay, so we need to know the time that has elapsed. That's actually 7/8 second. Let's take a look at another example. This is a dolphin example. A dolphin is jumping out of the water with an initial velocity of 32 feet per second. We can figure out after how many seconds he enters the water again. Now, because the water here is going to function like the ground. The surface of the water is like the ground, so it's where h equals 0. Write the model, define the variables. H equals negative 16 t squared plus vt plus s. Here again, h is 0. We want to know when he hits the water. That's when h is 0. The initial velocity is 32. That's given to us in the problem. And s equals 0 because he started in the water. Write the equation and solve it. Here we should put 0 equals negative 16 t squared plus 32t. The s is 0, right? Remove your common factors. This is a 16. We're going to remove negative 16 and a t. That means our first term now becomes t. That's a 32. We're going to remove the negative 16, which means it's minus 2. In this case, t is 0. Again, that's when the dolphin is leaving the water, so that's irrelevant to the problem. But in this one, t is 2. That makes sense. It's going to take him 2 seconds up and down. Okay? We're talking about the shape of a parabola here. So it's going to change a little bit. Take a look at these problems again. Make sure you can set them up, define your variables, and then factor them to solve them. So there are several steps involved here.